Alright. We are here. Get up here. Welcome to the design and chill session. Because, I mean, we're engineers. What else would you be doing, right? Yeah, tonight we're just catching up. This little session has been about, it's been about building some, like a 3D Delta picker. And I've got to get this turned down. It's in my ear. What's up, Ali Reza? How's it going? I saw someone in the lobby waiting, and I was wondering if that was gonna be you guys. It's like either too loud in my ears or not loud enough. I don't know about you guys, but YouTube music is like so difficult to get set right. Anyway, yeah, we're starting back up, kind of doing a little bit more of the Delta picker. It's been so busy this past week that I just haven't been able to really find any time to work on it. But I don't know if y'all can see my hoodie. I mean, most of you guys are from not the US, so you have no idea what this is. But everybody from the US, spam in chat in the comments if you know what this is. For anybody that's not from the US, the US is known for what, like 3 places, or I guess 4 places: New York, California, Florida, and Texas. Well, this is Texas. It's all Texas. It's literally a gas station. It's a gas station that is like the size of like a very much shopping center. It's kind of crazy. They have like 200 or 300 gas pumps, and they serve barbecue, brisket, all the meats. But anyway, enough of that. I was just, for some reason, the air conditioner is like really cold in this room, so just put on the hoodie, hanging out. So we're trying to get this Delta picker going, kind of where we left off since it's been so long. We have these 3 1FL6 servo motors from Siemens. I've got the V90 drives. I think I saw where DHL delivered them, or we're supposed to deliver them today, but they're down at the shop. But we're going through and we're designing a Delta picker, and we have made this little shaft coupling that I'm trying to design in a place that's strong, but because we're 3D printing this thing, I figure if we overload it, it's going to strip out. It's going to strip out on these little arms, and so 3D printed this little keyway, and obviously it's not long as it needs to be, but if it fails, hopefully it will fail in here. And then today what we'll be working on is, this is just like I just did a quick test print to see how long this arm would be, but we're going to scale this up, get it to the right size. So what's up? You're here. We're talking about the Delta picker. Yeah, people coming in from chat, from the Discord. If you weren't aware that we have a Discord's in the description. You can join up. If you have trouble, if you had trouble before, I had it expiring after like a week, that link, and so this link that I have in our descriptions doesn't expire. So if you're still having trouble, try with a VPN, because I have found out that for some reason some regions are blocked on Discord randomly. Well, I mean, I know why, but it's political, but whatever. But we're making these little parts to where we can slide, if we do strip out this piece, like if we over torque it somehow, we could just pull this apart, pull off the arm, and it'll spline off this little piece here, and then we could just print out another small piece instead of having to print out a whole nother arm. And then, so kind of building in a known failure point so that like we know that it's going to break there. And in general, that's kind of a good practice. Like, still have this over engineered for your point or for the system, but then you kind of want to design in a known failure point that's like, okay, I know this is the weakest point in my system, and I'm going to make that weakest point in my system to where that it's easily repairable or easily to be able to change out. Because you would hate to be having to like change out like on a real system, like the winders that we design. You would hate to have something that was like a really expensive part that is like custom machined, like high tolerance, and that be your failure point. You would much rather have something that's just like a piece of metal that you could just go out, or have a couple of extras that you could just change out. So that's the idea of this. Obviously, I just printed this out pretty quick, and I've got my 3D printer behind this, definitely not a wall. Yeah, and so this is like my wonderful cloth brick wall here in my apartment in Atlanta. But yeah, so we'll be, hopefully by the end of the stream tonight, we'll have some other parts 3D printed out, hopefully an arm or maybe to test this interface. Because one thing, if you haven't done a lot of 3D printing, is the tolerances. You can kind of like, oh hey, you can kind of like not guess, but you can kind of, oh hey, this is what the tolerance should be. But then when it really comes down to it, it's going to be you might be like 1/10 of a millimeter off, and if you're trying to get a really tight tolerance anyway and you're 1/10 of a millimeter off, it just doesn't work. It's just too tight. And so we will do some iterations. But yeah, so if you're in chat, I don't know how many, I don't have my like actual YouTube thing pulled up, like my studio thing. If y'all are in chat, be sure to say hey when you're coming in. Yeah, so if you're in chat, be sure to yeah, drop a thumbs up. We're just hanging out, doing stuff tonight. I know a lot of y'all are over in kind of the Central European time zone, so it's probably what, 6 hours ahead of what we're at right now, and it's 17, so 20, what is that math? 23, yeah, it's late. So kind of what we were talking about in the Discord was a little bit about ways that once we are actually get these drives going, we would go to, what's up LFC, another Discord, more Discord people. But yeah, once we actually get this Delta Picker designed and these drives going, again, these are the 1FL6, so this is a permanent magnet servo motor. We're using the V90 drive, so this is kind of a small boy. But if we were doing something a little bigger, we might be using S120. But the cool thing about it is with the 1500T processor and the kinematics, you would be able to use the exact same code. We were kind of talking in the Discord about how to actually control these, and I don't know if many people in here have any experience with like actual robotic companies like KUKA, FANUC, ABB, these kind of like industrial robot companies, and the way they do it, the way those companies do it, is they have all their designs and engineering like already pre-programmed. You don't have to worry about all the mechanics of it, and you're just kind of using, you set up at the end, do I have any way? You'll set up like a tool at the end of, like in our case, it'll be these arms will come down and create a, what's called a tool point. And so if you have this kind of tool point here, you program in the control system to understand where you're kind of like, either your pincher axis, something like that, or I did some ABB robot training up in the Detroit area, and one of the things that they do is they have a pin holder, and so it's like a spring-loaded pin. and so what you do is you use this big industrial robot arm to draw on a piece of paper, and so you like draw circles, and the first thing you have to do is calibrate up the tool point. And in 1500, in the Siemens 1500 kind of like technology objects method, you're still doing the same thing. So because your tooling can be different, and so you can actually change out, like from that pin holder, you could have a gripper head. And when you change those tooling out, like the actual reference point to where the work is being done changes. So in robotics, kind of like in the robotics realm, you have different tool arms, then you have different working frames. And so if you're familiar kind of like with the concept in physics of what your reference frame is, it's used a lot in modern physics, so like quantum mechanics and things like that, but then it's also used in orbital mechanics. So like with respect, like if you're in a car, you might not be moving relative to the car, but obviously you're going 100 kilometers down the road, 100 kilometers an hour down the road. Well, if you, in reference to the car, if you're holding a pin, it's not moving in reference to you. And so like if you toss it up, like if you throw it up in the air, it doesn't go flying backwards. Well, that's reference frames. Well, in your kind of like robotic world, you have different reference frames that you can talk to, and because you use the same functions, and you say, I'm going to be moving my tool point. What's up, Christian? How's it going? Everybody coming in. It's good to see everybody. Again, this is kind of a laid back stream. We'll probably be doing a the Motion 101 class tomorrow. So this is kind of just introducing the kind of concepts of this robotics portion of it. I probably won't do much of the robotics portion of it tomorrow. But because we're building the Delta Picker and we're working on this tonight, then that's kind of what we're talking about here. Which I kind of forget, like if you're joining in the midstream, like you wouldn't have seen like the very beginning, opening page with like the wolf, like and all that stuff. But we have a member. We have our first member of the channel, which is so awesome. I would be afraid to butcher the username, but we officially we have members that are taking part of this, and that's kind of like the next way to support the channel. We kind of had a discussion in, I think it was one of the comments or something, like that was what's the best way to support the channel? Well, for free, it's coming on, commenting, liking, and that's awesome. It gets out there. The algorithm loves engagement. You just being here, spamming the heart, spamming the light, like sending emojis, sending comments in the chat, that gets this stuff out here. And then kind of like at the membership levels, that really starts to kick in to get YouTube wanting to put our content out to everybody. So to become a member, there is a link in the description. To become a member, there's two different levels. There's a supporter level that is just to be able to help get this channel out there. And in return, you get the kind of the user data types and the things that we kind of, some of the files that we use on stream, you'll get access to those. Mainly it'll be like the data types and some of the functions that we might make like on the stream, like analog convertings and things like that. I'll put them all in an archive, and there's a Google Drive link that you can have access to those. The second level is what I call the programmer level. All of the files, all of the archives, like everything that we create on stream, you will have access to. And so if you're a member during that month, then whatever we do on the stream, I will put it in that Google Drive. You'll be able to play around with it. You'll be able to work with it. And I mean, honestly, some of the stuff that we do on stream, most of it is because of members and supporters like you guys that are coming out and saying, hey, how do you do this? And so I may actually end up doing a good portion of your project on stream. And so if you're a member, you get access to that file, and you can kind of go from there. And so, and yeah, you also will get recognition like on this little screen. I'll show you a little thumbnail I got. It's pretty cool, right? So, yeah, I'm not sure how to pronounce Wojcik. Well, I may not be able to, in my redneck dialect, be able to. Dude, LFC, awesome. Welcome to the programmer level. And awesome too. I'll start talking about memberships and I get two. So thank you so much for all of y'all's support. Y'all are so awesome. Yeah, it's great to see that. Yes, we are here. We are seen. Yes. And so yeah, so those of you that you're joining, you can kind of see in the membership or the member area, you'll have access to those links, and you will be able to do that. And I really greatly appreciate y'all's support in any way, just being on here and having a community and building a community. Some of the guys in the Discord, I feel like we're working through and we're kind of like gaining these kind of like kind of understanding and across the world. So I really do appreciate all you guys. But in the meantime, I was going to, we got to get over and do this sort of stuff at some point, right? That's why we're here. We are here to do some drawings, or not drawings, but some modeling. So we've been kind of talking about this, how this thing would be controlled. And again, like I was talking about, I'm going to go into some of these other things, but have Mr. Tordmain. Like, I'm sorry, I'm going to have to figure out how to pronounce my supporters' names. I'll do better, because I'm from Alabama. We have simple names like John and Jason, because we have trouble with with complex words. But we were kind of talking about the way that we have these different reference frames for our robot, and once you define this tool point, you have a bunch of different functions that say move this tool point in some way in a certain reference frame. So just abdo, awesome. Abdo, is it ah, like ah, or a, like ab, like my abs, or ob. But either way, I really appreciate everybody that supports, and as we keep growing, yeah, it's awesome. The more we grow, the more you get, more we could get out of it. So these tool points, as we start using these functions, and in the technology object world, there'll be things like MC, move circular, and the function definitions of those blocks will essentially define, all right, which tool am I using? So if this is the end effector, so we're going to be designing this this delta picker here. The end point of the frame is defined by the mechanics. Well, the tool is kind of like attached to that frame, and that's what the tool point is. And so you're going to have these functions that say, all right, we have this work piece, that's another reference frame, and that will kind of shift everything into that reference frame, and then I want you to use this tool that I already have defined, and I want you to move this path like a move circular. And in like the robot world, so like ABB robots, for example, those are like on a 6-axis industrial robot. You'll have a thing called like a J move, like a joint move. And what that joint move is it doesn't try to actually trace the tool path in any certain way. It is just taking and moving however it is to get to the orientation that you're wanting. And so there are other moves to where, for example, like a L move, a linear move, you'll put XYZ coordinates into that block, and it's kind of hard to see on the video, but I'll pull up full screen because you'll have these blocks that in 3D space you're wanting to move the tool point from here, way back here, up to here. And then you have a starting orientation and then an ending orientation. So we have these sorts of situations to where a joint move doesn't really care about what the tool point, the end point does. It just cares about reaching the proper end point in the proper orientation. So if this is the starting orientation and then this is the ending orientation, it's just going to move all of the joints of that robot just directly to it. And so the end point can flow around however. Well, a linear move, like an L move, is going to take into effect the fact that you have the tool point, and it's going to move the tool point in to make it to where it linearly kind of like orients like this. And I'm having to watch watch my little camera monitor there. So, but it's like you take and you move the end point here and move it linear to where it actually follows, and then you ends up at the orientation. So it kind of interpolates all of the middle points in between the two. And there's obviously some, well, it's not obvious because you don't have the equipment in front of you. Christian, welcome to the member. Like, again, thank y'all so much for going through and supporting the channel. Again, I love the fact that this is a way to get this channel out here and to get it out more, and I really greatly appreciate what your support of it in any way that you support. And again, if I think everyone who's joined today is on the Discord, but even if you're not a member, you can join the Discord and join in the conversations, and we have build a community of people working on different projects with different expertise. So thank you, Christian, for joining. So in the same way that we have like an ABB robot that has these functions, L move, C move, J move, L move, you have these similar functions in the Siemens technology objects. So once you set up the same tool points, the same reference areas, you're just saying, do an L move from here to here. So starting and ending coordinates. And then you will take and say, okay, I need to move from here to here. So what we will be using on this delta picker will be similar to that L move. So like if we're looking down at, say, like a conveyor belt that's going here, and we're wanting to pick from here to here, what we will do is we will most likely be generating a point, like a pick point, and we're going to come and grab it, and then we're going to say L move to some point over here, and then you can move over to it. Now, there's also moves that are like superimposed, because kinematics, this could be a moving conveyor belt, right? Well, if you have a camera and you see your object, when you go to pick it, it is not going to be the same place as it was when you saw it, correct? So there is a function inside of Portal, inside the technology object, that says, okay, well, here's my pick and place. Well, it's on a moving reference frame, which is kind of crazy to think about. So my reference frame is moving at a rate of the conveyor belt. And all of these functions are automatically updated once you get them all sorted out. And so you just say, hey, I'm in this reference frame, and you've defined that reference frame as being moving. So it knows, hey, that reference frame is moving, so I need to pick up from this point. It's at here, so it's going to move along, grab, and then shoot, and then come back and set down here. It's really cool, and all of those functions are built into the technology object concept. And so, so Abdo was asking earlier in Discord about what drive do you actually need to use. Well, I said, well, the V90, which would be these, the G120 with a control unit, CU250S control unit, or a S120 in the Dynamics line. Yeah, Ali Reza. Yeah. You were supporting me. You were supporting me just by your interaction with everything, and so yeah, the politics of stuff is not always fair to people in the countries that have the politics. And so, being from where I am, I fully understand that. So you could support me just by spamming the chat. That's how you can support me. And you already do so I appreciate it. So we were talking about like what drives you could use. The crazy thing about it is, we've mentioned this on some other streams, is that once we set this mechanics up and we get this the 1500T like actually running our Delta picker, we could actually change the drive hardware and just put on new motors onto the drive hardware and then just use the same code. And then we would just have to reset up the technology objects, but the code would be exactly the same. And so that's the power of the technology object concept that I talk about on a lot of my different videos. But your code doesn't interface into a drive. Your code interfaces into a specifically designed piece of code that was designed by Siemens that you configure to whatever drive you're using. And so they use standard Telegram. So a GSD file, like the way we're going to actually use the V90 drive is through a GSD file, and I think it's Telegram 3, I think. And so we'll be able to use that GSD into our Delta Picker technology object. So anyway, enough. You got me talking all about the drives again. It's almost like I have a weird obsession with drives. But let's go back to this. Let's talk a little bit about this. And so, again, if you have questions about kind of the drives portions of it and automation, like, feel free. If you're in chat now, I mean, we're here hanging out. Like, there's no real kind of like subject other than just kind of like messing around and doing stuff. So if you have a question, just go ahead, throw it in chat, and we'll talk about it. But tomorrow morning, I will be doing a stream that's Motion 101, and we'll be kind of talking about the different, like, what is motion, like kind of definitions of motion, and kind of like gearing, so positioning, gearing, camming, and then we'll talk a little bit about the kinematics, but probably not. That's probably a Motion 102 topic. But yeah, let's get here. I'm gonna start kind of like looking at what we got here, so like what we need to work on. So one thing that I noticed, so again, if you're not used to Solidworks, I am what I would consider a I guess competent, by no way an expert, but we kind of like set up this assembly and set up these kind of parts based on really I mean, just kind of pulled it out of my butt, really. I didn't really like plan to do this, but I've realized, because of the way that I made this kind of like spline converter, I made the key on the actual piece itself. And I was gonna make up, like, I was gonna say that it's like that's so that the failure point is here and blah 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 and all that stuff, which this whole concept is. But honestly, when I got these motors back from my customers, they had just taken the keys out of them. So I don't have the keys. What's up, Bartek? Welcome from Ireland. It's good to see some more European influences and kind of around that UTC time zone. So welcome to the stream. And yeah, so one of the things that I did was I was like, okay, I put this key on there because they didn't send the keys back, and I have a 3D printer and I don't have a key. But so I was like, all right, I'm going to slip this on. Well, obviously, as you can kind of see in the drawing up there, the cut for the key on this shaft obviously has to be round because it has an end mill that is round and it cuts that key. And so the keyway kind of like comes up and you could see it sticks off of the end here. And which is great because that automatically gaps our components to where it's not going to be rubbing. But we go from kind of this surface here. Can I hide this? Hold on. Hide. Yeah. So we kind of go from this surface, and our keyway is going to clamp off pretty much at this point. And so I was like, oh, well, I need to know how long I need to make my arm, because originally I was going to put another plate over here on this kind of to like support both sides. And then I realized that most Delta pickers that I saw don't have a supported, like both sides are supported. And so I'm like, okay, apparently there's not a whole lot of the forces that are putting a lot of stress on the bearing. So I'm like, okay, well, I'll just take that out because that'll simplify it. Because that was the whole point of this like weird cutout here, was because I had another piece on this side. And I'm like, and on the stream, I don't know if y'all remember, but I was like, how am I going to get this stupid thing on here? I was like, I don't know how I'm actually going to mount all of this up, like get the shaft onto here. And it's a little tight from what I'm looking at. So I might need to back things off. So like move things away. But one thing about these Delta pickers is like well, yeah, we'll figure out some sizing and stuff here in a second. But because I was measuring this, and if you measure from that little point that was there all the way out to the end of this shaft, of course, I picked the wrong point. Well, if you measure those things, so we could just do measure from there to there. Look at that. Look how crazy that is. It's 25 millimeters. Okay, cool, right? Well, if you look, and if we do a measurement from this face, from this face, I guess, hold on, I need to undo this. Why is that line converter? I want to see it. I want it to be there. So if I actually measure now from this face to this face, 25 millimeters. And somehow we got that like dead on the actual center line. We had actually lined it up somehow automatically, that it was actually split. Because if you measure from the center line to like this, there's like a DX 12 and a half. Have no idea. It's totally random. It's totally random that it gave us exactly the centered, because the thickness of this mounting face, I just picked what looked good. And it was like 7.5 millimeters, and it's like ended up being like perfect. And I had a totally different design from this. So anyway, I figured that out off stream kind of like 2 weeks ago, or I guess a week and a half ago, whenever it was afterwards. And I'm like, what in the world? Like, that would have been slightly annoying, but we're good. And so I could have told you that did it intentionally, but you're smarter than that. So what I wanted to do was, I kind of want to figure out now, because if I'm looking at this, in order for us to be able to slide this kind of spline and this like shaft over that shaft, we're gonna have to have this thickness, like, so from a measurement from like it's gonna have to be, it can't be this thick. So like I'm looking at this and I'm like, okay, this can't be this thick, because I need like whatever width. So like this to here needs to be 25 millimeters, because if I'm building a 25 millimeter shaft, then I can't get it off. Like, if, does that make sense? Because if we look at this, the shaft is going to slide on here. And the only other way that we would be able to do that is, I guess we could just put the shaft on, like, and then not have it mounted up. I just want to try to avoid annoying things. So what do y'all think? Should I like cut out a piece here in order to like, or yeah, let me shrink this. So let me just open this part. I don't know. What do y'all think? What do y'all think I should do? Because I don't know about y'all. I have a problem of seeing like all of the possibilities. And open part. And so sometimes that makes it to where it doesn't work. How did I do? Okay. How did I reference all this? Did that. Okay. I wonder how bad we're going to break this if I do this. Just like cut this in half. No. No. and the reason I'm just like, no, what are you doing? No. I will apologize in advance if I why am I get excited. That is Borkin. I don't know why I did that. So yeah, we need to definitely like bring this out to maybe like 16. I'm just trying to like balance the thickness of this. Why does when I say delete, it goes crazy? Because I'm not selected on here. I wanted to say 18.0. And I think that's what I want to do. And the reason this cut pattern is because this sketch is referenced off all the wrong stuff. And so let's go and re-reference this. Oh, this has a reflection, doesn't it? Oh, I didn't reference off the edge. Well, durr. Alright. We're blowing most of this up. Because this is all referenced horribly. So I did a... This center point cannot be deleted unless the endpoint is split. What? Alright. Whatever. Just kill it all. That's probably like not good to say on YouTube. Let us delete the thing. Delete the object and start over. So let's, no, we want a semicircle. Alright, yeah, because we did a semicircle and then kind of like rounded it out, didn't we? Actually, no. I remember what we did now. Oh. We did half of it. And then did two. I remember. Okay. Yeah, if you've ever done this type of stuff, it looks like when parametric things like lines give you problems. Is it proper to teach the industrial robots that you teach? So I'm not sure. I mean, there definitely is a way to teach the endpoints for sure. So Ali Reza is asking if, like, on an industrial robot, it's kind of talking about like the 6-axis. You have the orientations for everything, and then you kind of like can move it into a position, an orientation, and an XYZ, and that is teaching those, or the process of saving those points is called teaching. And so you teach the robot the points. And an industrial robot, a lot of, probably like 90% of industrial robots are just point to point, and they have a path that they are following. If they get off the path, they crash, something happens, it faults out, you got to redo everything. And so when you teach the points, you are taking your tool to where you want it, and then saying save that orientation and position. And then at that point, you're like, when you're in teach mode, you are going through and saying, hey, save this point, save this point, save this point, save this point. And those are kind of like built into, that is a specific mode that is built into the industrial robots. And honestly, we're gonna learn, because those, when I first learned about the kinematics, I was like, how do you do all these things? And I wasn't really familiar with the industrial robots yet. And then I'm like, oh, hey, no, I get it now. But the teach mode on industrial robots is really just a way to set the positions and those points and everything. And so I would need to look up and see like what type of options there are, if there's like a learn point, because I know that there's a path creator tool that instead of just using like point to point moves, like a circular move or a linear move or a joint move, there's a path move, and you load in essentially a bunch of like really small path, like small increments. And so it's just doing a bunch of like small incremental moves in order to go and do whatever. And there is a path tool, I mean, that you can kind of just load a path into this tool, and then that's a database that the kinematics path object or function, so like MC path, whatever it is, follows that path. And so creating that database and creating those lists of points is the process of like a teaching mode in industrial robots. So we'll have to figure that out. I mean, that's a good question. There's some to where you have like the collaborative robots and you literally are just physically moving the arm and manipulating it into positions. And like, I would think that you would be able to do that, the same thing, and just say, hey, here's a point. What's this point? Because like on the industrial robots, there's a mode to where you just like jog everything around, get it into position, and say, hey, learn that point, call it home, or call it pickup, and that is a point in position. And then in your code, you'll say, all right, do a joint move to pickup. All right, do a linear move to enter object, stuff like that. Cycling, interrupt, record actual position in array and sort in move absolute or something. Yeah, that's basically what it is. So, yeah, the path following is essentially like doing a bunch of absolute moves. And with the kinematic object, it's instead of just like one axis, you're doing an absolute move to. Because like an absolute move to on this is, so if I go from 0, we'll call up 0, and if I go to 90 and it goes whop, is that 90? Whatever, I can't really see it, but if I do that and that's 90 degrees, that's an absolute move here on this axis. And with a kinematics, like this has it has like you're doing an absolute move from a tool point, and in order to actually make that absolute move in 3D space, like this delta picker, you have like 3 arms that are in like the same plane. And so in order to make that move, all it's doing is just like modifying the positions of these motors. And so yeah, it's kind of wild, but yes, in essence, a path is just doing a bunch of really small absolute moves, but not on the motor, on the 3D kinematic space. And again, we're getting into kind of like the high end like motion concepts, and but yeah, like definitely be going into more simple stuff tomorrow that would build up to these sorts of things. But yeah, those are really good questions, Alireza. Like, I know because of politics, you may have a little less support there, that as everyone else is, or everywhere, or not everywhere, most every other places has. And so yeah, there's industrial robots kind of all over the place. And this is kind of the same concept. And so if you're needing to kind of build a solution, this is a really good awesome. Yes, LFC. So the kinematic object, actually, the definition. So I did a live stream, I don't know, it was probably a month ago or so now, and it was on a it was called Advanced Technology Objects, Kinematics, and I linked it in the Discord with Abdo. So like he was kind of asking about the delta picker and the kinematics and stuff, and I've referenced that advanced live stream and kind of talks about that in there. But yeah, the kinematic object you define, like on a delta picker, I only have one here, but like on this object up here, whatever. Let me scroll in and out. Hold on. Let me unbreak this. Unbreak. How much can I unbreak it? How far will it let me go back? That far. So it won't let me unbreak it. But anyway, so each one of these motors on this object here, each one of these motors is going to have one of these arms on it. And I mean, they're all in the same plane. And so in order for you're entering the length of the arms. And so that defines a mechanical relationship in 3D space of the endpoint and the combined coordination of the three motors. And so that's what the kinematic object is about. And it is pretty stinking cool. And that's really why when I found out I had misordered these motors, I knew what we were doing. I knew we were going to make one. So that's the beauty of the kinematic object. But yeah, let's see if I can get back into this to where I can unbreak this. Yeah, sure, whatever. Let's see. I mean, I would really rather not have to redraw this every time. So I would love to have this defined in a way like this. That's not a closed path though, is it? Oh, that's why I did that weird thing. I remember all this now. So one of the things about all this is so that's coincident. That's that. This needs to be for construction though, because we're going to reflect over that line here in a second. We're going to, I don't want that to be on that, because I want it to go out. So let's define this. I want that 2 millimeters. I don't think that's gonna work. It's gonna make a weird little thing that's too thick at that radius. Yeah, you definitely should check out that advanced technology object one. This needs to be like 3 millimeters total, so. Yeah, and I'm just kind of like visually in my mind picturing like, okay, what what is this actually going to look like once I do what I want to do? Because I'm going to do a what's it called? A fillet, or I guess it's a fillet. I'm going to do a fillet here, and I'm going to do the fillet the same as this. I'm doing a cut. So, let's see. We're going to do fillet here. Here. Entities to fillet. Fillet going to be added because the specified radius would eliminate. Oh, duh. Yeah, so we're going to do 2. 2. And then we're going to select that. Entities to fillet. Oh, I guess it doesn't have a definition to be able to go off of. I don't like this. It got weirder. It got weirder down on the bottom. But yeah, so like yeah, there. That's what I'm wanting. I'm wanting that. Okay. Can we just say yes to that? Yes to the dress? Yeah, I could draw it as an arc, and that's probably the better way of doing it. And I think the way I did it last time worked randomly because I essentially just it was a good combination of like 2 millimeters versus it was just like a good combination. So let me try something though, because what I want to do, because I'm gonna need an arc on this to go between them, and so it's like, so let's do this. Let's try one thing real quick. All right, no, I don't want to fill it anymore. No. And then unselect, bruh. Now I want to mirror entities. Those, I want to mirror it across here. Like my tooth. And then now I have to do an arc across from here to here to... Come on, give it to me. Wow. Yes, broke everything. Like literally broke absolutely everything. It's because it doesn't have a entity thing here. I'm sure that there's all sorts of stuff that's broken. Oh, it's because this arc, this guy. Oh yeah, I remember this now. I remember how I did this. I remember. Pepperidge Farm remembers. Ugh, sucks. Okay. Yeah, because what happens? There's intersecting entities here. Because I'm dumb. What did I just delete? I just deleted the wrong thing. No, I didn't. I want to delete this. Yeah. See, I need to make an arc from here all the way around to here. And so I need like a center point arc. And then I need to set this outer circle as for construction. Because if I want to make this tooth going all the way around here, it just seems a little... I don't like how long that is. Let's do this. Let's do this at 3 millimeters, please. Of course, that's how you would choose to do that. Because that and that make them coincident. That and that make them coincident. Okay. Now when I do this, it's gonna break. Of course. Why is it gonna pull the... whatever. I try to make this length shorter. It's... What is constrained here to where... Yeah. Anyway. So now what I was wanting to do is make a yeah, that might actually, yeah, you're right. Or I could just say fix. But yeah, I could, you're right. I could do a... Oh, that's kind of dumb, but there's a radius. Whatever, it's fine. And then now, if I redefine that... Yay! Good job. Thank you. Thank you, LSC. Yeah. Yeah, so you gotta fix all the stuff you don't want to move. So, dimensioning for people like me that don't know. So let's see. So now, how did we do this last time? We went through and did a... See, we're still gonna have the problem of that cutting it. Oh, what am I doing? I just realized something. I'm not a smart man. I don't know why this isn't messed. Because these teeth have to come out of this cut. Yeah, so we're just gonna slowly back away. We're gonna uncheck this. We're gonna say, build that. I was working in the wrong one because this is the actual sketch I needed to. I was like, this is gonna give us an open unit the whole time. Yeah. Yeah, so that's well, what I was gonna do was like you said, revolve the sketch. But in that, by doing it the way that I was doing, when you do that revolving, you'll have an open, that circle will not be open. By taking it away and doing it here on this sketch and cutting it away, you are you don't have to worry about having an open circle. So like before, the reason I had to change that, that like outer circle to a construction was because it had two different closed circles and it didn't have a way to resolve it. So this is actually the drawing that we need to be editing. And so just to make sure that we're actually editing the drawing that I want to edit, let's go through and do that again, and let's make a for construction circle that is just concentric with that. And so we want to say that this, and will it let me select? It won't. Normally you can cancel. I'm trying to like go in and be like, I want this, but you can't get that because it's in this sketch. Whatever. Anyway, so what we'll do, go in here, delete all this, do this again. make this circle. And then this will be kind of what we build off of inside of here. Got one tooth. Yeah, that's what we're doing. I'm just making one tooth here and then gonna revolve it. I just somehow I clicked too many times and got into the wrong sketch, and so I just have to rebuild our drawing here in the correct sketch. Wish I could do like from here to here because it just looks so much better. Yeah, whatever. So we'll fix that. Say okay. And then we want to take this, make this 3, was it? It's a little bit of a tooth. And then do our fillet 1 millimeter. Flip that away. And now the kind of like trick to this is actually, yeah, because we can, yeah, because we'll actually close this loop. So what I want this to be from here, 1.5. And then now we can take and select from this way, deselect that. Which line is it? That one. And we want to mirror across this. And then we want to take our 3-point arc. And then we want to go from here. We want it to be outside here. It has to be outside of that. I hope that's outside of it. Whatever, it just has to be outside of it. Oh! Yeah. So I had this cut, and so I just had to make the pattern for that cut, and then that circular pattern is the revolved cut. So I just like mess it up by shortening it. I shortened it out of the tooth because for some reason the tooth was not actually in the like referenced to anything. So anyway, so we've got this. Do I want to like? I want to do this slightly as well because the way I had the other one. No. That just isn't going to print well. So, I don't know if that's going to print well. You want good, strong connection point like in your interface, but yeah. So, all right, whatever. That's good. So we'll try this. I'll print one of these out here in a minute. Actually, I could probably just go ahead and get that printing. Hold on. I'm gonna be lazy. Trying to see if I have glue on my... I don't think I have glue on my base. Stop doing that. Like, that's annoying. Yeah, I've got glue. I've got some glue right there. I stick and love my bamboo. I love it. So absolutely love it. I mean, so we kind of had this conversation. So in the Discord, you have measure once, cut twice, or measure twice, cut once. He actually is my he replaced me at the previous company that I left from, and so we know each other in real life, and he has a, what is it? Is it a Persa Pro? It has kind of like all of the same features of this, but it's not just like enclosed and have all the like cameras and all of this stuff. But I think that Pro version is like $600 or something like this, where this has like the AMS system, so has like all of the filament like management, just heated bed leveling, like all of that. This one is about like, I think it's like $1,600. And to me, I like when 3D systems like lost, or their patent ran out, they came out with all these like maker like 3D printers, and I had one. Like I had one that just like put together, and it was a nightmare. But it was only, I mean, it had like I think it had like 100mm print, like 100mm cube. Like, I mean, it was very small. But it was a nightmare to actually get things to print, just because everything, you had to manually level your bed. It didn't have a heated bed, but it was like $150 for the printer. So this one, if you can afford the $1,600, it makes it to where you just like don't have to worry about it. It comes with the software that's like this, that like yeah, it just makes everything really easy. So but also at the same time, you're probably not going to learn quite as much about 3D printing if you have a like really like printer like this. And honestly, you might find that you don't really use it, so it might not be worth it to you. But if you're just kind of looking to see if like you would want one, I think the I want to say, I can't remember what it was. Bring it up in the Discord to like at measure twice, cut once. Just like at him in the Discord and ask him what his printer is, because he has one has a lot of the same features: auto bed leveling, and yeah, Prusa. Yeah, it's like a Prusa Pro, I think. But it's like an open frame type, whereas this one's all closed. I think he has like a the AMS, like the filament management thing, is really good. So let's see. We're gonna do spline inverter IT. Yep. D2. And then we're gonna do save as new. Did I just fork that in a way that I didn't want to do? Yes, I did. Because this part is not V2. No, it is. Okay, Solidworks is smarter than I am. So X just exported as STL. Then we take this. And da-da-da-da-da. Where is that? I have the memory of a goldfish. Oh, it's in my Google Drive. Delta picker. Where did I need to put my... Where do I see the glue? I see some right there. That's like front right. It's like right there. No, I don't want it in black. I want it in white. I want it rotated because I'm not smart enough to rotate it in the here. Yeah, I'll just get this printing while we're going about it, and then we can kind of work on all the other stuff. Slice that. Okay, I don't care about your daily tips. What? Oh, that's, I just learned something new. That's actual layers. You actually go through and see it. Pretty much hollow on the inside, isn't it? Do not like that. Sparse and fill density. Let's go like 40. It's still not. Yeah, it's a little better. There's just not a lot of space in there, is there? Oh, I didn't actually change it because derp. There, much better. Okay, so let's just go ahead and print that. PLA. Yeah, that'll be done here in a little bit. All right. So. Where are we in the... Oh, go. Hour and 20 minutes. It's fun just like hang out and just whatever. I wonder if Ali Reza's still here. It's only like 5 o'clock in the morning there. Are you going? Are you doing your thing? Oh, it's, yeah, it's going. Alright, so we can go back. See, the cool thing about the Bambi Labs is I like have trust in it. Like, it's, for the most part, as long as the filament doesn't get wet and it doesn't have a hard time like sticking to the bed, then it's got like this laser like detection system in it. So it actually looks at the layers and it will actually go through and examine layer by layer as it's going. And so it will go through and like say, hey, I've detected like a spaghetti failure or something on this. Do you want me to like, and it'll break off and then you can kind of clean it up and then you can go in and like have it try and recover. So it's pretty cool just to be able to like, all right, we did this. Now we can just go about and just forget about it. Here in a few seconds, I'll check it you could see it's even got like cleaning off the tip. It like it's kind of annoying because it'll just like spit out a bunch of filament in order to make sure that the filament is like good consistency, but it just like drops it out the back of the thing. And the way I have mine set up is it's like just falls down behind like the dresser that's sitting on, and there's like all of this like piled up little pieces of plastic that are down in there. So it's kind of funny. My wife loves it when she goes to like clean up. Yeah, it just like pooped it out the back of the machine and onto the floor. But yeah, so yeah, let's go through. And now, so here's the way that we're gonna have to figure out, because I want to do an inverse of this pattern and somehow figure out how to do the inverse of this on this other object. Which, so I wish I could just be like copy and paste, you know? What's a reference sketch? No, that's not what I wanted. Unmake a reference sketch. Make edit sketch. Yeah, so what do y'all think, if y'all got some people on here, what do you think the best way, because what I'm wanting to do is I'm wanting to take out of this, I don't even have it out here right now. So let's just open this up. Open. So this is our arm. And so now I'm wanting to build up this arm, bring in that part. I think I know how. If we could bring in an assembly and then edit this in the assembly, I think we can reference off that assembly. But then that cut is going to be in the assembly, not in the shaft. Maybe that's okay. Maybe that's what we want to do. So what I'm kind of thinking about doing is, how do I actually make this spline pattern on here? And so I know for the first thing I'm going to need to do, that is fine. Except I'm going to need to make a part in the assembly environment. Yeah, so that's kind of what I'm thinking about how to do. But sometimes though, that will create that. So you can edit like a part in an assembly. So like if we go over here and I bring in assembly, I bring one of these in, and then I like do the mate to where it gets over there, right? This is horrible because it's not in the right plane, but you get that assembly over there and put it on there, and I made it up. If I edit this part based on this assembly and like redo this cut, it will this cut will become only in the assembly, which I guess technically would be okay, because then I can't pass that down. Let's try it. Let's just do that. So first things first, we need to get this the correct size. So right now it's extruded up, and then I have a cut that cuts out the whole thing. So we want, so this is, what's this measurement? Yeah, I think you can, and that's what we're going to try to do, is edit the part in the assembly. Um, and I'm pretty sure you can do it. Like you can actually edit the part with the references from the assembly. It's just sometimes I don't do it the right way. All right, it looks like it's going to print. So what it's doing is calibrating the extrusion, and you can tell if these lines don't look good, and so it's actually going through and like doing like a laser examination of these little pulses, and then it'll actually correct for the extrusion. It looks like my filament's a little wet, but anyway, if this doesn't stick to the board right there, you basically just go through and put more stuff on it, and then it'll go through here in a second. It'll start printing. So sorry, I just heard it doing its little boop 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 sound behind me, so I wanted to check to make sure it's stuck. So let's look at this real quick. So let's do a measurement. I want to measure like this circle, but I mean, we could just do this. Get out of here. So that's 32.04. So that's what 32.04 is going to be the diameter. So that's, I don't know why. Well, whatever. So that's that. 32.04. 32.04 for that. Now we're going to go back to here. So that's in diameter. So edit this. So 32.04, and we want 5 millimeters on each side. Sounds reasonable, right? So that'd be 32.04, 5 millimeters, so 42.04. And that should give us enough room for that. What? I guess it doesn't, something doesn't exist anymore. Well, that's dumb. Alright, that's good. What is it that's... What is it that's broken? Yeah, you can. In the actual... so like if you just wanted to... Like when I was making that dimension, you can just go through and... Yep, yeah, you can. And it'll just spit it out. So it'll just do like 32.04 plus 10. It'll absolutely do that. So why is this not? I don't. Oh, because this is a side extrusion, and then I'm cutting through instead of doing it extruded out like you're supposed to, like an actual person that knows what they're doing. Anyway, whatever. We'll just go with it. So this hole is going to have to be this distance. Alright, I don't know why this is... That does not exist anymore. Bruh. Why are you... I'm deleting this relation. Stop being a stage 4 clinger. coincident. What is this coincident relationship? Like, like, line with what? Like, okay, there. Now, I can do from here to here, and that needs to be so that's 32.04 minimum, then plus the other one is going to be the outside is, yeah, so that has to be 42, so like 42.04 divided by 2. Like that. So, there you go. So that's just kind of our pilot borehole. And if I remember correctly, the fact, oh, I see, that's why that cut is the way it is. If I want to fix this to make it to where it actually looks right, we're gonna do something like this. Hold up. We're deleting this for one. We're going from midpoint there is for construction. For construction. Now we're going to do a little bit of work here. That and this coincident. Yes, finally, it looks so much better. All of the obsessions of like the little stupid stuff, but like making it to where if you want to make a change later, you're not having to do stuff like this. Because I figure we're about to have to do stuff like this. Like major stuff like this. Alright, so we go down. Go back here. Go rebuild. Yeah, you go rebuild. You go rebuild. Alright, so now I want this. Let's do a mate, this, and that. Eccentric. Change this. Doesn't make things difficult at all. Mate, this. Face. I want the face. Give me the face. Give me the face. My face. There we go. Wee. Alright, so now we need to modify. So it's like we can go like right here and like edit this extrusion. We need to edit this extrusion. And we need to go 25 millimeters here. Rebuild everything. So that extrusion went that way, right? So this, why did I make it this way? Why did I do it this way? Because now I have to like go in and edit the sketch. Because this is 25 millimeters. And break everything. Yeah? Rebuild. And How we looking? How we looking? No, not that. This one. Still not right. Why did I make that extrusion that way? Why am I not a smart man? Look, I want to edit the sketch. I want to edit this. 25 millimeters. I say yes. I say yes. I say rebuild. Now that works. Yay. Alright, that's what I wanted. See, because now I can do this crazy stuff here. No. No. Set up this view. There, I just wanted to cut away so that now I can say go normal to. Fuck. All right. See, now is where I think we can go through and edit this. Like edit this hole in order to the shape of this, but I don't quite know how that's gonna work. Alright, so let's do this real quick. Let's do a mate here and here. No, that is no. Undo that mate. I wanted this to like be. We have no music. We have no music. I can hardly hear the music over the sound of the whoa, 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 whoa. This guy. See? So how do we do this? How do we do it, chat? How do we do it? I just want to mate this. I want to mate this surface. Mate it. I want it like, oh my gosh, like that. I want it to be parallel. Indeed. That. Okay. Now that's locked in. Yeah. And now, okay, so get out of here. Oh, we have our part's done. So, that also tells me it's been 20 minutes. It's been 20 minutes I've been working on this thing. So, now, so we have this cut here. That I could edit, right? I could just edit it right here. Like, edit the sketch. See? I can do this. I can do this. Alright, because I can see these. It might work, chat. It just might work. So, how do we make that shape? Because we need to cut out this hole. So this has got to go bigger out to here. And then we're going, and then do the revolve. We do everything in accordance to that, but then we have to offset. Ah, bing, there you go. Good job, chat. You came up with it. Now, we're going to use the offset entity of this. Then we're going to offset it off. But how? Let's see if we can do that. Will that work? So I want to offset entity. I want to offset it by like 0.1 millimeters. Oh snap. Are you freaking kidding me? And then we just... Look at how smart we are, chat. I'm sure that there's some better way to do this. Yeah, so this... If you edit it in the assembly environment, that edit will only be in the assembly. And so in order to make it like... So this... that is what I should be doing right now. Is doing an edit on the part so that the part... Because otherwise if I make an edit in the assembly, then when I go to actually print the part, those edits will not be there because the edits are in the context of the assembly only. So what I'm doing now is using the assembly as a reference in order to edit the actual part, so that when I export it as an STL and send it over the printer, yeah, that's literally what I've done. So I've gone through and in the assembly environment, opened up the sketch, and I have edited the sketch. Yeah, that's what I'm doing. It's just like zoomed in and I have it all skeletonized because see, I have the assembly here, and then I have gone into my tree over here, and I am editing in my arm. So in my arm, I'm editing this cut extrude. I'm editing the sketch for the cut extrude. So I know it may sound the same, but there is another way that you could do it if you're not in this thing in the tree, in the actual part in the tree. So this is the assembly tree, and I'm editing the part in the assembly tree. If you go through and say outside and say like make a cut, you can select a face in the assembly to make a feature, and that creates a feature in the assembly context itself. And so it will not be in the context of the part. And so the part doesn't actually know about that feature. I'll show you here in a second. Let me finish up on this and I'll go through and do that. I'm sure that there is a better way of like doing this like offset entity, like selecting all of these features, but it's such a complex feature, so it's probably not. I mean, I probably could just offset an entity and then revolve it in the same way. That's probably an easier way. I kind of like doing it this way for right now. Do it the hard way, just so we appreciate an easier way if we find out later. And then I won't be oh no, why was I so dumb? I used the wrong thing. I meant to hit control. Up, da, 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 da. So fun. I'm glad though that once we do all this, there's like only like 2 more parts that we actually have to make in order for this delta picker. There's like the hinge portion, which is an interesting little concept because you have like you have 3 degrees of freedom in each one of these, the endpoints of this arm. So you have a rotary on the end, but then, well, I guess it's 2 degrees, and then you have like a this way. So it's like on the end of this arm, there's like the pin that goes through it can rotate, and then on the end of it, it has to be able to shift back and forth as well. So we'll be designing that kind of like pin shaft here in a second. If I can. What? So like peaceful with the tediousness. You guys here, hopefully you are about to go to bed if you're over in the European time zones. About to get some rest, moving into a Good Friday. And you get up in the morning, or when I get up in the morning, I'll be doing a live stream for Motion 101. Pretty much talking about a lot of the stuff that we're talking about today. What? I'm sure that the easiest way to do this would be to do an offset of one of these and then just rotate it. But I want to make sure that it works. I know here in a second I'm gonna like accidentally click on the wrong thing and it's gonna break everything. The graphics card is about to die, isn't it? Running like OBS Studio, all these other things. Solidworks, an assembly model. Streaming out to 4 different monitors. Actually, why do we even have that one on? Don't get distracted, Jason. You're almost there. You're almost there. You could do it. Just one. A few more clicks. Don't down me. Don't down me. You're so close. There. Oh. 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 Break. Oh yeah, because I just... Okay, that's fine. That's in the... How... What? Alright, what do we have here? Did I just... Uh-oh. Mates in Delta. Okay, yeah, delete that. It's like we don't care about that one. Yeah. But this guy. Oh, it's just out in the middle of nowhere. We did all that work. It's so close. But then we drew it on this, and then it does, like, for some reason, ugh, whatever. All right, we have this sketch. it will work. It will absolutely. We can select all. Why is that not like there in that center? That's what I want to know. What have we done? Yeah, that's what I'm thinking. But the problem is I don't think there's actually a center up here on this drawing. Because that's in the, like, all of this doesn't actually have a center. Alright, let's see. Let's see what we got going here. Let's do this. Bunch of crap. What's that? Oh, that's the actual offset entity. Okay, that's cool to know. Oh, we just drew it up there. Okay, let's try this. We're gonna fix this real quick. We're gonna fix it. And when I mean fix, I mean we're gonna fix that thing. Oh, I see what it's doing. Maybe not. Yeah, see that's what I'm trying to. I thought we had drawn this in the correct way with it referenced, but then it just kind of died. We got the teeth the correct way from the offset, but so what? Let's do this, and let's take this, and let's fix this. Oh, see, the problem is like that center is not actually in. That is in the drawing. That's in the assembly reference. I have some like reference, like planar reference sketches, and so that like circle is not actually part of this sketch, I don't think. But let's go back here. Let's undo what we just did, because I do need that. So that means I can't fix this because it doesn't like that. Let's go down here now. Select this. Okay. Yeah, so what we're creating is kind of like a splined. So I have one of these, and then I'm making a shaft to go over this. So I'm kind of making a converter shaft because this is plastic, and I'm assuming that if we ever bind up this arm, then it's going to want to break off this like the key, and so I'm trying to make it to where I can just print off another one of these, slide it back on, and then repair the arm. So what we're doing right now is making this kind of, we've modified this pattern, and now we're trying to cut out that pattern into this to where they will slide together. And so and we're trying to do it, and the only real way that we come up with it was doing it in the assembly. But now let's take, it would be really nice if this was all referenced off of this like that, and like that. It would be really cool. It'd be really super cool if it would just, we could say, hey, they're coincident, and it not break. No, not that thing. Point. What is this point? Yeah, that's that point. That's the point that, yeah. So can't make that coincident, but see, I feel like there's like a circular distribution thing that we could do on this, and then like could do that, but there's not like a relationship that we can make with it. And if we just select these, yeah, and like just like move them down, it's not gonna work. It's like just like move it. All right. So MC 101 will start probably around so 10 o'clock. 10 o'clock here is probably when I'm gonna start, and so that'll be I'm UTC -5. So yeah, so I'll be doing in the morning just kind of like an actual motion control 101 class, kind of going through about kind of like the introductory to what we're doing here. But yeah, we're just kind of hanging out right now and trying to figure out how to do this design work in on this Delta assembly. But we'll say we did talk a lot about kind of the kinematics, how we're going to do all of that, but I'll definitely have a kinematics specific one on this when we start trying to control the Delta picker. We're just got to get it designed right now. I mean, I could easily just go through and make this keyway in this shaft and stop trying to be so fancy about this, which I may do, but I don't like giving up so easily. So if we took, I don't know why it moved this. I don't know why it moved that, because it was perfect, and then it moved it, and so it's like, Control C, maybe. Are you kidding me? Are you kidding me? I just did Control C, clicked on the thing, and Control V, and it centered it up. Yeah. So now I'm gonna undo that, and instead of doing a Control C, I'm gonna Control V or Control Exit. Control X. Deleting the offset dimension. Remove the offset relations to sketch. Yeah, never mind. So what we're gonna do with this is we're going to... No! Come back here. We just figured it out. Undo whatever I did. Yeah, I definitely just cut and pasted it. So let's see how bad we have it now. Yup. I don't know why, but like some chats just will pop up. I can see them and then they disappear. But I think we have done it, chat. We've done it. Look what we have done. Look what we've done. All right, let's see. Oh, the little victories, chat. The little victories. But watch it be like impossible to modify. I will never modify it. So we just printed this thing out. So I'm going to print this thing out now. Actually, I'm gonna have to pause for a second, and then I'll have to like clean off the print bed, put a little more glue on it so I can print this out. But what we can do now is go in. We're gonna save this for one thing. Save all, rebuild and save. Don't be borking. And then we're gonna go to the arm. That looks awesome, but I don't know if 0.1 millimeters is gonna work, but we will see. All right, let's go to it is new. We're going to do as STL. Let's save that. Yeah. Yeah. And then that was good there. Woofy. We'll prepare. We're gonna delete that. We're gonna drop. We want it. Nope. Want it this way. 90. Alright, be right back. Alright, so we got this, got that. That looks pretty good. We can go down on this because slice. Yeah, that's fine for this one. This is test fit. I don't know, hold on. Okay, I guess that's all right. This thing just looks like a different size. Not gonna lie. Not gonna lie. Looks like a different size. But it isn't. Actually a little tight, but... Interesting. Just notice the... I mean, just the ever so slight bit of differences in the prints. But it just looks so... Like this one visually looks like it's bigger. Like, I'm like, how did it get off? But it just looks like it's bigger, like the bore. But this one is actually smaller than that one. It's crazy. Crazy how that works. Alright, what we got going now? What do we want to do? We want to try and figure out this. Let's take off our sections. Not that. And we're going to test fit this here in a little bit, but now I want to try and figure out if this is actually going to work. Let's see something. Alright, let's do a mate. This face, mate with this face. Alright, whatever. Because what I'm trying to do is how do I get a reference, like some sort of like center point reference here? Anyway, I guess I can put this. So I have used Siemens NX, and I have also used Siemens NX MCD, which is the mechatronics concept designer. So it's the actual simulation software. It is very similar to Solidworks. So it's parametric. It's very, very similar to what you have here. It's not like Fusion 360 or Solid Edge. I tried to use, well, I guess Fusion 360 is parametric, but Siemens has a package called Solid Edge, and I could never. It was all like, yeah, it just wasn't parametric, and so it was all like visual. It just didn't. I learned on SolidWorks, and so a long time ago, and I'm old now, so yeah. But NX is really cool. It has a lot of integrations into the what's it called? The Cinemeric, which, by the way, next week? No, not next. 2 weeks. So like the first week in May, I'm actually going to be taking a Cinemeric commissioning class, because Alpha is going to be becoming certified to do machine tool retrofits, so CNC equipment, and I have a little, I say a lathe, like it's got like a 48-inch Y-axis on it, but yeah, so this gonna start doing metal work, because I mean, when you're designing your own stuff, it's super easy to just like 3D print stuff out, but now just imagine taking these files that you come up with here and then put them into metal and then have your own equipment. So we're gonna be doing that too. So I want, like, again, I want delete that. I want like some sort of, because I can't quite do this. So I want that face and like that face to be like that. Yeah, sure, that's fine. Then, oh, that's, that wasn't the right mate. That was like coincident. I want it to be parallel. Where's my mate? Mate. Oh, no, maybe I did. No. Convert to parallel. That's what I want. Because I want to be able to move this and link that up. So, so NX, so there definitely is. We were, I guess, were you asking this in the Discord earlier? because there definitely is some packages that that tie all of that stuff together simulation wise, and yeah, it kind of comes down to, I don't know if so NX, I don't think there's a package that does that, but there is an add-on to so it's an add-on to NX called the Mechatronics Concept Designer. And unfortunately, I went on trying to like find all these. I think they've renamed everything. But there was a package called NX MCD, and so it was a plug-in to NX that would take your model and you would be able to connect it to what was called was it Simit or Simulink? There was a simulation to where you could actually tie the Portal PLC, or actually you could tie the processor itself into a model, and so you could do a simulated PLC, and so the package that ties those together is a package called there's PLC Sim Advanced, and then gosh, I want to say it's Simit, but I think that's wrong. Maybe it is Simit. But there is a package that can tie all of those things together, and there's a higher level of So PLC Sim is one of the packages. It's the one that simulates the PLC, but then there is a link, and I believe it's Simit, that links the PLC Sim to like the actual model. So you have all these points on the model. So it's like, oh, hey, this axis, this value inside your PLC corresponds to this axis here. And there's a package that ties that together. Yeah. So that works. So now I want... So... I don't know if this is going to work, chat. I don't know if it's going to work. Did we go the wrong way? Did we go the wrong way, chat? I think I'm going to stop my print. Because we went the wrong way. Yeah, we're not going to waste that. I know for a fact that's not correct. Kind of hard for kinematics, but basic. Yes, so I know PLC. So Simit has absolutely a package for like hydraulics and things like that, but there is it's actually yep type F in chat for respect, to pay respects to the part, because I definitely did it the wrong way. But see, that's the part of like going into this assembly and zooming in, and I'm like, why is this not lining up right? And then I'm like, because I'm not a smart man. So let's go back in and let's fix that. And yeah, I'm gonna go over here real quick. So I'm gonna pull this up, and you can like watch my shame as I try to do this. Go down. All right, be right back. I'm gonna pull this. Yeah, that definitely wouldn't have worked. Definitely wouldn't have worked. So, let's try. Let's see if we can go back in and... Why is this the wrong way? Oh, because that's my spline. I need to go out. How did I get that wrong? And now with these offset entities like this, ugh, that's annoying. All right, so, all right, chat. We're rip. Delete it. We are going to delete it. Oh, Control A. Oh, maybe not that. Maybe not that. Let's not go overboard. So let's just select everything up here, and then unselect my little circle. Oh, that's a lot of stuff. That's a lot of stuff. Bye-bye. Painful, but let's y'all help me not be like smooth-brained. You have to yell at me. You have to yell at me if you see it. Good to see that some of y'all are still hanging out. Yeah, so if you're kind of joining in randomly and this is not normally kind of what, this is the hang out, chill, relax, just kind of go through different stuff, sessions of this. Normally this is an automation channel to where we do a lot of stuff with Siemens drives, Siemens technology, and when you're doing automation and you're doing with drives, you end up working with mechanical stuff. And so one of the things is like, everybody's like, hey, how do we use these kinematic functions? How do we use these extra technology objects and stuff like that? And like, there's only so far you can go without like an actual only so far you can go without having an actual demo, and so that's what we're doing today. We are designing and building a Delta picker. Now, obviously, if you can't tell, I am not an expert Solidworks person, but how did I do this earlier? I had this earlier. It's so crazy. Anyway, I had it earlier. So let's... Oh, yeah, so it reverted. This serves. Register that thing. Yeah, so not sure the question, but yeah, I also have an advantage of owning a industrial automation company, and so we have stock of 1500 Ts, so 1515 Ts, TFs actually, and I had a project that I had these servo motors that I ordered the wrong size of them for, and I had 3 of them, and so, well, yeah, it's costing us some. Like the learning and training that we're getting is definitely worth it, and so, yeah, that's definitely one advantage of being able to be like, okay, yeah, this might not be making money, but it's still worth it because of the training aspect of it. And so the only thing that I actually am gonna have to buy for or have bought for this project, like that I didn't already have, is gonna be the V90 servo drives, and they're at the shop. I don't live in the same area as where our shop is. I'm about a 3-hour drive away, and so they get all delivered to all of that. I live in an apartment here in Atlanta, so yeah. But how are we gonna do this? Because that. So, like in here, because there was a sort of reference. So like rebuild this, and then I have my section view. Did that. And now in that, I edited the sketch. Oh, I see. I see what happened. That is the actual... That's the boss extrude. How did I get that? Like, come on, how did I get that? Because that's an offset off of something random. This is all fun. Yeah, so if you were to actually build the buy the components in the US, and now the US, these components are a little bit more expensive just because political reasons, because they're the V90s. think it's about $3,000 total for the motors and drives. So $3,000 US for those. And then the PLC, the 1500T, is about $3,500. Then you have probably maybe like $300 or $400 more so of just electronic components. So yeah, you're looking at, you'd be looking at like a total cost of around $8,000 US for the electronic components. And then, like, again, I'm just printing these right now, but we also have a machine shop to where we can actually build the hardware components. So just the cost of materials are probably a few $100s. And so you'd be looking at probably around $8,000. Yeah, around $8,000 in total. But again, that's we're buying it at fairly inexpensive prices, and then we have the ability to build everything. So that would be much different. But it also, like, in different markets, those prices are going to be less, because obviously if everything is more, or you're not going to be able to charge, or Siemens isn't going to be able to charge as much in a yeah, so yeah, you could probably, if you had a machine shop and like all this, like an ABB Delta picker, it's probably going to be on the order of around $13,000 to $15,000. Yeah, and it's really about the experience of putting it all together. So you're totally right on that. And that's where it's like, that's the big thing that's worth it. I will probably end up, I have a little farm in Alabama that we're going through and kind of automating some stuff. I will probably end up putting this on that farm, like picking eggs off of a conveyor belt or something. But it's really more about the experience of being able to do it, because if you go through and, at least in the US, and you design a Delta picker sort of thing, even if you just buy a mechanical Delta picker and you have this experience to be able to do that, yeah, I spend $8,000 or so to be able to put it together, but then you could easily just in one project make 100,000. So yeah, well, I don't know about steppers, but there might be a way to do it actually. The problem is like the controller itself. If you were kind of going the lowest end way of doing this, and you were just wanting an inexpensive Delta picker, then it would, like, there's CNC like open source CNC controllers that you can do this sort of stuff with, and yeah, use stepper motors and the arms. Oh yeah, so that's, yeah, so there's like a package, an open source package that it's it has an arm controller. I can't remember what it's called, but it's actually a same package that does like 3D printers and those sorts of things, but they have kinematic versions of those that are all open source. And so you could probably do this entire project, especially like the little like the plastic version, for maybe less than $1,000. But then you wouldn't be able to leverage that experience into the industrial world. And that's kind of like owning the business makes the kind of like the experience a little bit different, because I could sit here and go through and design this, and yeah, if we have a customer, we have a Delta picker design that we could go through, and I've already written controls for it, you know? And when you would charge a customer for that, like, you charge what it's worth. And if someone else goes through and is like, okay, they go buy an ABB robot and to integrate it, it costs $100,000, then I've designed it, I have this stuff, and yeah, so it might cost me $15,000 to design and build their version of it. But with the technology object version, or the technology object concept, because I did it on the TCPU, I would be able to actually use that code on like an actual industrial thing. So even if I went to like S120s and like a bigger version, this code would run on like a full-size ABB style robot. And then I could make probably $50,000-$60,000 off of, like, I could make that off of it. So yeah, it really is about the experience. And sometimes, again, it goes back to like the blessings of just having the opportunity to do that. Because if you have customers that are willing to pay for these sorts of things, and like, then it's worth it. Yeah, spend 10,000, make 50. So yeah, it'd be just another solution that could bring in to your customers, or to our customers. So, and it's fun. And why go through all the stress of running a business if you can't have fun? You know? So like, if I deleted this, what's there? That's there. But that's an offset entity itself. So that's there. I need to do this, don't I? I think that was the big difference. Yep, that was the big difference. Wireframe. Sorry. It's fun just to kind of sit, chat, and talk about different things, and at the same time do some cool design work. All right, here we go. All right, yeah, I can actually find it now. I'm gonna do this a little different this time. So instead of doing this, I'm just gonna trace out this one thing the same way I did it before. Then I'm going to revolve it. So I'm going to create an offset entity of one tooth. Like this. Because I really don't want to have to go back through and select all these. See, that is the opposite way. So, no. Am I about to do the same dumb thing that I did before? So that is that. I need it to go the other way. Reverse. Reverse, reverse. I have to offset off these too. Why is that? Why did that? Just visually, like, yeah, so I need that to be smaller in there. Okay. Okay. Now. Why is it not letting me? Oh, it did. This visual bug weirdness. Now we're going to do a revolve pattern. Circular. Where's the point? Oh, we're going to do this point. What the heck? Oh, so weird. Oh, get out of here. Want these? We want to do a circular sketch pattern. Delete that because that's not where I want it. I want it on this. Point 11. There we go. Now, how many of these do we have? Yeah. Is that it? Why does that look like it sucks? I think this is... What's going on with that? Let's wait until you get some steel scars. Yeah, so I mean, scars are interesting. To me, they're I know they're fast and simple, but they're just weird. Yeah, so what I like the full intention would be, because there is a what's it called, a synchronization function. So we were talking about this earlier, and there is a way to actually sync it to where if you have like an object that's like rolling on a conveyor, the reference frame is attached to a conveyor, and so when you fire that command, it knows that this conveyor is moving, and it knows that it can like go to that point and grab it like at that point. So that actually is a function that's already built into the technology object. So we definitely are going to be trying to get all that going for sure. See, I think I got the wrong point. That's why. So weird. What the heck? Why do you gotta be so weird? Alright, so like unselect that point. Is that point just like random in space? It is! Oh my gosh. I don't have any points over here, do I? No. Alright, let's try this again. Offset entity. No. Circular sketch pattern. We want 16 of these. Alright, y'all ready? We have a point. It is not that. A point. We are going to go and try to... Oh, I broke it. I clicked the wrong thing. It's so hard, chat. It's so hard. Yeah, we're trying to have fun on this. This is definitely humbling me. I literally could just go through and print a stupid key into this, but I'm being stubborn. I'm being stubborn for you, chat. But I am kind of getting hungry. I'm gonna get this. We're gonna get it. Okay. All right. Let's see. I'm gonna do this. Control C. All right, you ready? We're gonna do this. I'm gonna see how bad this is. What? Will this not build? I think I've broken it. Okay, there we go. Yeah, I mean, in metal, maybe not, but I just like, I would love to have to make a replacement one of these parts instead of an entire arm. So that's why I'm like trying to stay the course. But it is trying me right now. It's tried me. Boom. How does it associate with divisions of press outside the sketch, see the sketch? Do you want to delete it anyway? I don't like it. I don't like it, chat. Yeah. Yeah, it definitely, I mean, a lot of engineers, or I guess some engineers think that, oh, they can design something to where it won't fail. And I have been humbled enough to know that that's not true. And so, yeah, I want to design it robustly to where everything else can be assumed to work, and then give it a place to fail. I don't like this. I don't like it, chat. Because now if I do Control V, oh, who knows where it is? But I don't like it. I don't like it. Let's try to figure out how to do this outside in the other sketch, just because we gotta do it out here. We gotta do it. We gotta do it the right way, chat. Yeah, this is definitely being designed to be conquered. Why is it so hard? Why does it have to be so hard? Alright, so I just want... Oh, is that my reference, or is this my reference? Maybe that's my whole problem. Maybe I'm doing the wrong reference. Maybe that's literally what I'm doing wrong. So the coincident is line and point 11. What is point 11? Point 11 and line. And is that line? Okay, that's my bisecting. Oh, and that point 11 is the between these two. Okay, I gotcha. I gotcha. And that is also point 11. So I want to see this. I'm probably gonna got about 20 more minutes that I'm gonna work on this. So we gotta fix it in 20 minutes, chat. Because I'm getting hungry. I'm hitting a wall. I've been working since about 7 o'clock this morning. It's now 7:30. So, fun days though. That is one thing though that's like good about like building up to where you kind of like have your own business and doing your own work is like I normally set Mondays and Tuesdays to be a little bit lighter, but then Wednesday, Thursday, and Friday I'm like wide open. So yeah, that y'all that are like over in the like positive UTC time zones, the Eastern time zones. Or I guess, yeah, the plus ones. I'm like -5, so yeah, got. I guess we have some people like in like Philippines, Indonesia, those places. I mean, they're probably getting to work right now on Friday. It's probably about 7:30, 6:30. They might be coming in early. So if you're coming in, you're from Indonesia, have a cup of coffee. Yeah. So, yeah. What is keeping you up at 3 a.m. like that? Why are you up at 3 a.m. watching some random dude stumble through SolidWorks designs? That is a good question. I mean, I'm not complaining. I'm glad you're here. I love it. But I probably also won't be able to go to sleep until like midnight tonight too, so out of curiosity. Hey, well, if you have to work in the morning and it's gonna make you tired, then you can watch this on demand. Yeah, you just can't interact in live stream and be a part of my pain as I like am so scared. I mean, this doesn't work right now anyway, so I don't know why I'm worried about it. So I really want to like delete this thing. But see, there's like actually 2 objects. That's the part of the problem. I made this like for construction, which was like some weird offset entity that like was part of the problem. So let's just do this. Let's just do it. All right, let's just go here. Get all that stuff. I want to unselect this, unselect this. And unselect the point. No. Unselect the point. Yep. Bye-bye. Yep. Don't show it again. Don't show it again. I'm committed. We're committed, chat. Oh, that's not even in the object. Okay. Oh gosh. Where's the center? Okay. Yep, that's it. So. We're gonna do this again. That is what I want. That is the direction that I want. I just feel like that's not quite enough, but okay. Commit. Okay. Why do I do such things? I think that's my problem. Keep clicking these things. It's fun to just sit back and watch me struggle. See, it's the only way you can really learn sometimes is just like work through something difficult. And I feel like there is the way to do this. There's 16 of these. Why is it off? Why is it off? What did I put? I hit 0. point. Point. What's this? Coincident line, point 11. What is that? I mean, that's the right thing. Is it just not showing right? Is that what it's doing, chat? We're just gonna go with it. I just don't think it's showing right. It's definitely not showing right because there's like overlapping crap. I have not done this correctly, chat. My pain is complete. Well, the spline is difficult. Difficult things are often worth it. All right, let's delete that. I want to delete that and delete that because that is causing me problems. This is okay. And this is like the literal reason why I did what I did, and the like the whole point of what I did. So let's see. All right, we're gonna try something. I'm just gonna put all these together. Delete. We're gonna pick point. Why is that off? That does not look right. Oh, that was dumb. That was dumb. Why would I do such a thing? Because I'm not paying attention. So, point 1 here. Need 16s of these bozos. So that's 30.08. See, that looks like do I just have like the wrong number here? Am I that dumb? No, it's 16. Oh, it's off. Is it off-centered? So it's pushing it off? I think it'll print though. We're gonna have to go do this sort of stuff. And that's gonna break. Yeah. Yeah, I'm probably defeated tonight. So, yeah, I'll see you in the morning. Yeah, so we will be doing Motion Control 101 in the morning, so it's good luck to see y'all there. I may continue to just be in pain on live. I just feel like there's a better way that I'm missing. So it's like, what am I doing? What am I doing with my life? Because I guess I did this earlier, and I just individually went through and did all of it, and it worked. So why don't I just do that and like do it the way that I did it before? That would just be simple, wouldn't it? See, I don't think this is like centered up anymore because I lost my reference. So it's like, okay, here's that reference, but then I don't have this sketch reference. Like, I need to be able to, so it's slightly off center. So would that actually match up? Because look, that's there. Which I guess I made it that way. How do I get a concentric? How do I set up a... In that, I need to make a sketch in this plane. Right plane, this. Oh gosh. Alright, let me do this in the actual. I do not need it in. So I'm gonna make a circle. Come on, rebuild. I'm gonna make a circle in this. Because like I need to pull this circle out so that I can use it in order to make the whatchamacallit, the reference. So how do I now, since that is part of that, I want to, in the right plane, I want to do a sketch, and then I want to, am I in this, am I still, yes, I'm still editing. So I just want to do circle. And then it's for construction. And then that's fine. And then now in this, I want to edit this. What is this coincident with? 0.2 and 0.3. Okay. It's 0.2 and 0.3. Is that 0.3 or 0.2? No, it's not showing me the actual. It's point. What's the point name? See, that's 0.11. Then what is that point on that back one? On that other one? Dadgummit. Assuming that that's it. Because there is a relationship there for construction. We're shipping it. So now I should have a way to now I should have this line that I can reference, or this circle that I can reference off of that's actually in the, yeah. So now I can actually, should be able to do a, like a mate. So like, mate that ever so slightly different. Okay. Alright, so yeah, so whatever, that's fine. Maybe eventually if you come back and actually see me on demand, you'll be proud of me. Alright, so let's do this. Let's do it! Alright, I'm ready. I'm ready. We're gonna do it. We're gonna do it, chat. Here we go. No more excuses. because now I have a sketch. I could just go. I don't want to delete everything. I'm still scared. Except I think that's just delete it. So dimension has been referenced outside seed of a sketch pattern. Yeah, sure. Just blow it all up. In YouTube, when I say that, talking about inside the drawing. All right, let's try this. Let's try it. Let's select all of these. Okay. Wish I could like. Try this one last. Try it this way one last time to see if that had any effect on it. See that's just ever so slightly off. That's why. Like I don't know where that is. That needs to be where that is the actual center line. Okay, that's helpful. It's not completely jacked up right from the beginning. That is not the right point. That is the problem. So I want to do out of this sketch. Why will it not let me select the sketch I just made? That's not the right place. No. We'll do it this way. Forget about it. We're just gonna do like we did a minute ago, and it actually worked. It almost killed my computer, but it worked. I was just dumb and did the offset entity the wrong direction. Are you freaking kidding me? Are you kidding me? How did I exit out of editing the sketch? I hit something the wrong way. I'm getting tired, chat. That is for sure. You reach a point where you just start making dumb mistakes. It's like not holding down control. Is that what I did before? That may have been why it broke. Boo, boo. Please, someone on demand, come through and tell me the easy way to do this. I won't be mad. Won't be mad at all. What's broken? Probably a mate. That's fine. Yeah, cool. I deleted that circle, I guess. The point. Oh my god. Alright, I think we finally have got it to where I can print it. Print it. We're just gonna delete that sketch because didn't really need it. Never mind. We did need it, didn't we? Undo that. Undo that. Undo. 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 Let's edit this real quick. What is it complaining about? Man. Get. No. Look, just delete that. Just need it for the reference. Alright. That actually looks how it's supposed to look. Now we can actually go through, save this, Yeah, save all. Now we're gonna go down, rebuild the arm, and I am going to be getting. All right, so now we're gonna go through, rebuild that, save as new. We are going to save it as STL because we're about to print it out again. Yep. Yup. All right, we got that. Got the bamboo. Got bamboo. All right, that's the wrong STL. That's the old one. That would have been really embarrassing. And do the green 90. Slice. I'm just looking at those like little edges, how they come out. Make sure that they actually have stuff in them. I don't really like that, but whatever. I don't think there's anything that one. Who cares? Alright, so let's print the plate. White, bed leveling, all that stuff. Yep, send it over. I'm gonna go get some food. It's dinner time. That's 2 times through the genre, dance, and electronic mood calm YouTube playlist. So I feel like we've been going for, yes, 3 hours and 13 minutes. So anyway, I am going to let this guy print out, and I'll maybe give y'all a community update, or I'll throw it on the live stream in the morning. But yeah, it's been fun. It's been nice just to kind of sit back and yeah, hang out, and yeah, we could do all of the like what's it called, the fun chat stuff. So thanks for everybody that stayed up, that was over in the eastern time zones, and I appreciate those. If you're watching this on demand, it's been awesome. Thank you. We've got a lot more automation stuff on the channel, and again, this is kind of the laid back one. Normally a little bit more structured, a little bit more practice, but this is just showing, hey, there's always something that you're going to be learning, you're going to be struggling through, going to be fiddling with. And yeah, so if you're not subscribed to the channel, please subscribe. And if you are one of the many people that I see all the time in the chat or in the comments, and you were able to support in some way, there's a couple of different membership levels. I'll be uploading these files to the programmer Dropbox. And so once you hit a membership level for the programmer membership level, you get access to all of the files. So I'll be uploading these assembly files, the part files that we've done today. Obviously, they're kind of like very specific, but you can kind of see the stuff in the way that we're doing, and you kind of play around with them. And yeah, so with all that said, thank you for everything that you've done so far, and just in support of this channel. It's been growing amazingly, and just appreciate all of the different faces from all the different walks of life, different areas, all over the world. I really appreciate it, and I hope that you have a great evening if you are here in the US. If you are elsewhere in the world, I hope you have a great morning, because you're probably about getting to work right now. But yeah, I appreciate all the support, and yeah, so just... yeah, we will see y'all later. And as always, I've got to update this because we had some members that joined in, so you'll see the update on the what's it called, live stream in the morning. But anyway, I'll see y'all. Y'all have it easy. Take it easy.